All right, so welcome back to the Water Resources and Environmental Engineering section of the Civil FE exam review. In this video, we're going to be looking at testing and standards. It's part J. That's in the handbook. So we're going to look at a few practice problems. Just want to note that a lot of this stuff is conceptual, and it's not like you're going to need to kind of know this or have some prior knowledge on some of these things. So that's why I'm here, to hopefully help you and give you some of that prior knowledge so that on the test you're not completely confused. Okay. So number 1 says, which of the following is associated with the corrosion of sanitary sewers? All right. So we're given, that corrosion is taking place, and this is in a sanitary sewer. We're trying to find basically which seems like compound is associated with it. All right. So if you're just taking a wild guess, right, maybe if you look up corrosion, maybe something may come up. Corrosion. Signal word, eye corrosion. Detailed corrosion data, acids, copper, bronze, steel. Don't see any of the nitric acid, hydrogen peroxide. Okay, so some stuff for chemistry. Just learning a few things that I'm paying attention to is the loss of like electron. They give you some definitions, which is pretty cool, but still don't. Looks like hydrogen is involved a little bit. Normal hydrogen, but corrosion. It's like H2 is reacting, but for the main, I don't see. Okay, so this didn't really help me. So you have to have some prior knowledge, is my point. Okay, so would it be H2S, BOD, fats, oils, greases, or NH3? Your answer is going to be H2S. Now I did make some notes for you here. So what is H2S? It's like a hydrogen sulfide, right? And it is often associated with the corrosion of sanitary sewer. So if you think of hydrogen sulfide, that is what corrodes sanitary sewers. So let's say you have this pipe with all the poop. See if I can get a brown color in here. We'll try that. So we got little pieces of poop. I would call it something else, but I'm gonna keep it professional. And so that's what's going through your sanitary sewer. And so pretty much H2S is a gas that is pretty much produced by the decomposition of organic matter that is in sewage and wastewater. So When H2S is released into the air, it can oxidize and form sulfuric acid, which is very corrosive. This acid can contribute to the degradation of concrete, so it's messing up your concrete piping, metals and structures in sewer systems, and leading to corrosion related issues, right? So monitoring and managing the H2S levels is really important, so that you can prevent corrosion and maintain the integrity of the structures. All right, so H2S, just a little background on those. And I'm gonna do a quick search. I don't. What is NH3? Ammonia is NH3. Ammonia is very dangerous. It means without water. It's used in nitrogen fertilizer. Not really a thing you gotta worry about for sewer and corrosion specifically. Fats, oils, and greases. It's not necessarily gonna corrode things. If anything, it might make it better, slippery, or it could clog. One of the two, but it's not gonna corrode. BOD. Biochemical oxygen demand, amount of oxygen consumed by bacteria and microorganisms, conditions while they decompose organic matter under aerobic conditions at a specified temperature. So still not dealing with corrosion. All right. Just for peace of mind, I wanted to go through all of those. All right, let's look at number 2. What strategies are commonly employed by nutrient removal and wastewater treatment to control nitrogen and phosphorus discharge and prevent eutrophication? Okay. So would it be so we're trying to find a strategy, right? And you want it to control whoa. You want it to control nitrogen and phosphorus, right? Discharge and prevent eutrophication. Okay, so any formulas needed? No. What prior knowledge? So physical filtration? No. What about B, pH adjustment? No. Chlorination? No, that's going to be more of for disinfection. Biological nutrient removal. Okay, so you're trying to control or remove nitrogen. I would say that that's probably the best answer. So what is eutrophication first and foremost? So eutrophication is an excess richness of nutrients in a lake or other body of water. It's frequently due to runoff from the land. So you got some rich nutrients in the lake, really too much of it. It's crazy. Okay, so biological nutrient removal is a wastewater treatment strategy, basically that uses microorganisms to remove nitrogen and phosphorus. Pretty cool. It involves 2 main biological processes: nitrification It's the conversion of ammonia to nitrate. That's cool because we were just talking about ammonia, and it's pretty dangerous stuff. So get rid of that. And then denitrification, it's a conversion of nitrate to nitrogen gas. Okay, so BNR is effective. BNR, biological nutrient removal, is effective in reducing nutrient levels in treated wastewater, and thereby preventing eutrophication when discharged into into receiving water body. So just some background there. If you don't know where I'm getting this information from, or done some pretty in-depth research, you can check out definitely the solution sheet. It has this information on there. As you're practicing and going through stuff, important to have some notes there for you. So if you have the course, all of these resources are available to you. All right, let's look at number 3. What are the key principles of biological treatment in wastewater, and how do microorganisms contribute to pollutant removal? All right. So some things to unpack here. So let's say given information. Well, we got these microorganisms, and we want them to remove pollutants. And we're looking at some biological treatment in wastewater. So how does this occur? Okay. And so formula is needed. None. We're going to need some prior knowledge. So what about, so going through our answer choices, all right? A, mechanical filtration. No. Biological treatment. So no. B, absorption or adsorption. No. I'm gonna search what adsorption. AD. Absorption is the adhering of substances from gases or liquids into the interface of two phases, mainly into solids, right? So we're dealing with microorganisms. So what about aeration and microbial activity? Yes. Microbial activity. Yes. And then chemical precipitation. No. So C is our best answer. Kind of has the answer in the microbial part in there, but I have some notes for you. So biological treatment in wastewater involves the use of microorganisms to break down and metabolize organic pollutants. Okay. So aeration provides oxygen to support microbial activity. You give it some air, and now the microorganisms. And what is a microorganism? You got bacteria, fungi. They utilize this oxygen to biodegrade organic substances. Cool. So bacteria and fungi are not bad when they get some oxygen, right, for our water. And so the microbial breakdown of pollutants result in the conversion of organic matter into simpler, less harmful compounds, right? So this can influence the the effectiveness of biological treatment include, or factors influencing the effectiveness of biological treatment include the temperature, the pH level, the nutrient availability, and the types of microorganisms present in the treatment system. So if you got a lot of bacteria and fungi, that is actually going to be utilizing the oxygen, breaking down some of this stuff, removing some stuff, removing pollutants, then you can get this organic matter that's a lot less harmful to us, which is a great thing. So it's a little bit of background. So, all right. So that covers testing and standards for water, wastewater. And so in the next section, we're going to be, I believe this may not be the final section. Let's see. Yeah, so once we get to K is going to be our last section with water and wastewater treatment. So looking forward to jumping into the next section, and I'll see you in the next video.